Okay, we are going to solve systems of equations, and we're going to do that using a couple of different methods. And we're going to start by solving by graphing, which is graphing both equations on the same coordinate plane. I guess maybe we should talk about what a system of equations is first. Two equations with the same variable is a system of equations. Ordered pair that is a solution to both equations is the solution of the system. You can get one infinite or no solution. So let's see what happens when we graph these two equations on the same coordinate plane. First thing I'm going to do is go 1, 2, 3 down. Y-intercept is -3. Slope of 1, up 1, right 1, up 1, right 1, up 1, right 1. And I connect my dots, and I do the best I can to find all my points. And then I'm going to graph this guy next with +1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. And we graph that guy there. And we are focusing on, remember, what a graph is the set of all ordered pairs that satisfy a given equation. So the red one is all of the points that satisfy y equals x minus 3. So you have -3, 0, -2, 1, and so on and so forth. And then what we're looking for is this guy right here, 1, 2, -1. 2, -1 is going to be the 1 point that works for this guy and this guy. So we call that the solution to the system of equations. We said there's 3 things that can happen. We just saw the idea of intersecting at one point that has one solution. Then we could have infinitely many solutions, which is the same line. It's one line on top of the other. And then you have parallel lines. Parallel lines never cross, and so there is no solution. There are no points that they have in common. More often than not, you'll get one solution, but we need to find out the other ones as well. Let's skip over to this problem right here. First thing we're going to do, we're going to solve these algebraically because it's not always going to be easy to graph. So when I'm looking to solve with substitution, I look for a variable that stands by itself. And I'm going to add 2. I'm going to move the 2 over, and I get x equals 2y minus 3. Now, the idea of substitution, since x is equal to this, that means they're the same value. And I'm going to take this guy right here and replace the x with it. 3 times 2y minus 3 plus 5y equals 24. Solve. Distribute. 6y minus 9 plus 5y equals 24. Plus 9 plus 9. 6y and 5y, 11y equals 33. Divide by 11, divide by 11, y is 3. Take that value, substitute it back up here. X equals 2 times 3 minus 3. X equals 6 minus 3. X is 3. My solution is always an ordered pair. Please make sure you write it as an ordered pair and put parentheses around it. We should go back up in here and check it. 3 minus 6 is -3. Good. 9 plus 15 is 24. Good. We have a single solution. These would intersect at one point. Next one. Substitution tells us that I'm going to solve for this y just to take a look at what might happen. Y equals -x minus 2. Take that -x minus 2, plug it up there. 2x plus 2 times -x minus 2 equals 8. 2x minus 2x minus 4 equals 8. Plus 4 plus 4. 2x minus 2x is 0. 0 equals 12? Question mark? What? Not equal. If something is not equal, then that means it's untrue. And if something is untrue, that means no solution. And if something is no solution, that means these would be parallel lines. So when you solve all the way down and get something that is untrue, that means parallel lines, no solution. Okay, substitution again. I can do this guy with substitution. Look at this. They're both equal to y. You can set them equal to each other. 3x plus 2 equals 4x minus 2. I would subtract this way because that's going to give me 1x, and I would add back that way. 4 equals x. Take that, put it back up into one of the originals. Y equals 3 times 4 plus 2. Y equals 12 plus 2. Y equals 14. My ordered pair is 4, 14. That's a good example of we probably wouldn't have graph paper that reaches for 14. It would be a pain to do it by graphing, so let's do it by substitution. Next one, I'm going to solve this for x. X equals 1 minus y. 3y plus 3 times 1 minus y equals 3. Threes are wild. Woo! Here we go. 3y plus 3 minus 3y equals 3 minus 3 minus 3. 3y minus 3. Well, that's 0. 0 equals 0. Well, when is 0 equal to 0? All the time. We have an infinite number of solutions. All solutions that satisfy the given equation. Yay! So we just saw one a little bit ago which had no solution because we canceled everything out and we got 0 equals 12. Now when you get something that is true, that means all solutions. Okay, next method, elimination method, probably the most commonly used method for whatever reason. What we want to do is we want to get the coefficients to be additive inverses of one another. And remember, additive inverses mean add together to get 0, because these ones are nice. This one's teed up for us. X plus negative x is gone. Negative 2y plus 3y is y. Negative 3 plus 9er is 6. Y equals 6. Now we need to sub that back in here. We get x minus 2 times 6 equals negative 3. X minus 12 equals negative 3. Y equals negative 3 plus 12 plus 12. Got a 9er. My answer is, whoops, that should be an x. Sorry. X is 9, 6. We got to plug back in. Is 9 minus 12 negative 3? Yes. How about the other one? Negative 9 plus 18 is 9. Yeah, so they both check out. There is my solution. Isn't she lovely? Isn't it wonderful? Good times. Yes, one solution. Good. Now, sometimes you don't have nice coefficients. You need to examine the coefficients. 2, negative x, 5, 3. I think if I multiply this whole equation by 2, I would have negative 2x plus 6y equals negative 14. And if I just drag this guy over and say 2x plus 5y equals 3, now I'm able to combine them. And look at that. Those will cancel out. We want to get them to cancel out. We want to eliminate a variable. And I get 11y is negative 11 divided by 11. Y is negative 1. Now I got to sub that back in. I can sub it into either equation. It doesn't matter. I would substitute it into the top one because there's a negative in there. Negative people are bad, and so are negative signs. 2x plus 5 times negative 1 equals 3. 2x minus 5 equals 3. Plus 5 plus 5. 2x is 8. X is 4. The answer is 4, negative 1. 4, negative 1. Plug it back in and check. plug it back in and check. 8 minus 5 plus negative 5 is 3. Negative 4 plus negative 3 is negative 7. Okay, now we have problems that are x's and x's and y's and y's, and again you want to examine 3 and 5. I could multiply the top one by negative 5 and the bottom one by 3 and we could go. 4 and negative 3. I have a positive and a negative, so I'm going to multiply this top one by 3 and this bottom one by 4. Because now I will have 12y and negative 12y. So you want to examine before you start. And I get, on the top one, I get 9x plus 12y equals, holy cow, what's 27 times 3? Must be about, 81. On the bottom, 20x minus 12y equals 64. So we're multiplying here, here, and here, and we're picking numbers that are going to have us eliminate. Look at this elimination here now. Elimination. And I get 29x equals 145. And I divide by 29 and divide by 29, and I think that's 5. And I get 3 times 5 plus 4y equals 27. 15 plus 4y is 27. Minus 15, minus 15. 4y is 12. Y is 3. X, y. Plug back in and check it out. I get 15 plus 12 is 27. Good. I get 25 minus 9 is 16. Good. There's our answer. Elimination, when you have to multiply them both. A little bit more going on there. So why elimination over substitution? If I tried to use substitution on this problem, I would end up with fractions, and most of you don't like fractions, and fractions are not your friend, and it eliminates errors. If we do elimination, this is going to be a funky one. So the first thing I have to do, I got to write this in standard form. So I get negative, I got to write negative 3x plus 2y equals 9. So I can move that over. Now, when I multiply this by 2, notice I get negative 6x plus 4y equals 18. On the top, I have positive 6x minus 4y equals 15. And see what happens here? These go away, these go away. I get 0 equals 33. When is 0 equal to 33? Never. And since it's never equal to 33, we have no solution. And we have parallel lines. So please understand the difference between what you get when it's no solution and what you get when it's all solutions. If I had 0 equals 0 or 33 equals 33, then it works. So they go pretty quick when they're no solution. You got to get them into standard form first before you can do the problem. So I would distribute this one by 2 maybe, and I get 2x minus 6y equals 6. I got a third, so I can do 1/3 x minus y is negative 4. Maybe I multiply both sides by 3, and I get x minus 3y equals negative 12. And then if I multiply this one by negative 2, I get negative 2x plus 6y is 24. Look at that, I got 0 equals 30. Can't do it, no solution, parallel. So when they're all screwed up like this, the first thing you got to do is put them together. I think we're good. You can work on your homework for 3-1. Make sure that you note of whether or not they want you to solve by how they want you to solve.